in the process of putting the packet together, so that when you get into the homework, you've got some kind of an idea of what their expectation is. And your book is actually pretty good at putting examples in of a lot of that stuff, too. It says solving systems by substitution. For a linear system, that means where x and y both have exponents of 1, you don't usually use substitution. Don't need to, usually. It says solve one of the equations for x in terms of y or y in terms of x. Then you substitute, then you solve, and then you check your answer. Substitution would mean I take a look at these two equations. This x has a coefficient of 1. If I have to use substitution, I'm going to solve this first equation for x because it's easy. I wouldn't try any of the others. Well, and you'd say, well, why? Because if I try to solve this guy for y, I'd have a coefficient of 1/3 on x. I'd start having fractions, and you don't want to do that. Fractions as answers are okay, but you certainly want to try to avoid as much as you can in the fraction world. Then you take this x and substitute it in for x here. So this says that 3 times x plus 5y equals -9. X happens to be 3y plus 3. Oh, -19. And now all my equation's going to be in y, so I can find y. So this says that 9y plus 9 plus 5y equals -19. 14y equals -28. Isn't that cute? Or y is -2. I have the y value. So if I'm looking at a coordinate point, x comma y, y is -2. Now to find x, I know that x equals 3y plus 3, or x equals 3 times -2 plus 3, which is -6 plus 3, or -3. So my solution is -3, -2. As a coordinate point, you could write it as x equal -3, y equal -2. I personally don't care which way you do it. Your book tends to want you to write everything in coordinate points. I think a lot of that is to try to instill the idea it is a coordinate point. And by the way, this is an error right here. I did not get it corrected in the master, and I wondered if that was the case. That's not 265, otherwise you're in big trouble. That's a typographical error. This is 26. And that makes life so much better. Trust me, I know I did that. Now this says you can solve the system by substituting an expression which is common to both. And what you will notice is this. This says that ax is equal to 3y plus 26. But in the second expression, I also have an 8x. So I'm substituting 8x for 8x. Now, if you're going to take trigonometry, that's going to be kind of a common thing that you're going to do in the trig world. Don't do that so much in 213 at all, and you're looking at the calculus world. In 213. 220, you've got a different animal on your hands. So that says that now the 3y plus 26 will go in for that 8y. So therefore, 3y plus 26, that's 8y, minus 5y equals 38. I'm going to put this above here. This ends up being 8x minus 5y equals 38. So 8x gets replaced by 3y minus 26. y plus 26. So now bring the y's together. So minus 2y equals, if you take the 26 over, you're going to end up with 12. I don't know why I was having a problem with that. Or y is negative 6. So now I do have the shared y value, and I'm going to need the x value. Well, what do I know? I know that 8x equals 3y plus 26, or 8x equals 3 times negative 6 plus 26. 8x equals negative 18 plus 26. 8x equals, this is so cute, 8, or x is 1. So what we have is x equals 1, y equals negative 6. Or the coordinate point 1, negative 6.